Okay, welcome back. This is Lab 1-5, Ohm's Law, I versus R, or current versus resistance. All right, so the objective here is to demonstrate the relationship between current and resistance with a constant voltage. Our equipment is an Elworthy power bench. We've got a tapped resistor, 200 ohms, 225 watts. We've got connecting jumpers, and we've got a multimeter. I didn't use the analog type, I'm using a digital type. Okay, only because we can see a display a little bit better here. All right, so the purpose of this is we're going to connect up this tapped resistor once again. We're going to move our connections at different points there and be able to then measure the voltage across those situations. We can also probably install, I've got an ammeter connected up to measure the current that we have, so we can see the change in current with the change in resistance and the same fixed voltage. All right, so the step that most students miss is you actually got to go back to a chart back here and look at table 1, and they ask us to measure the resistance of this tapped resistor, from there we could look at calculating the current, and then we could actually get the actual ammeter reading. I'm not going to do the calculated current portion of it. We can do that, or you guys can do that as we go through, but I will basically measure the resistances here. I'll power on after we've got it safely connected up again, and then we'll be able to measure the actual current that's flowing in the circuit. So I'm just going to try to tighten up the screen a little bit here. Okay, maybe a little bit tough to see. Hang on one second, I'll adjust so we can get up a little bit on this guy. Pardon me shaking the camera here. Okay, so if we're up like so, and we come down on there, now maybe you can see the meter's a bit better, and you can see these points I've got labeled. This is 0 or O, point A, point B, point C, and point D. So that's O there, A, B, C, and D. And in our chart here, they ask us to measure the resistance between O to D. So that would be across the entire length. And remember, it said it was a 200 ohm, 225 watts. So let's see how close the tolerance is on this. I've got this fluke meter set in ohms. I'm going to go from that terminal to that terminal. And you see we got 191 ohms. So I'm going to record that one, 191 ohms. Okay. And then they ask us O to C. So I'm going to go back to this one. We're now tapped at about the 75%, so we're at 147 ohms there. I'm going to call it 148 because it's 147.8. So I've rounded up. Okay. O to B. We're at about the midpoint, so that's around 100 ohms, which in this case is 102. They've repeated O to B twice. Okay, so we can skip that. We can just go to O to A. And that's 54 or 55 ohms. Okay, I wasn't the one that created this chart and duplicated the O to B. Okay, so that's that. We've got the measured resistances. Now they ask us initially to connect it up from O to D in the drawing. On this page here, we'll just zoom in on that. So we're on this figure 1. That's step 1 there. I've got a voltmeter connected in parallel with that to measure the voltage drop across there. I've also got my ammeter connected up in series on DC amps. And we're connected up to our DC power supply, so we're ready to go. I'm going to just sit down here. You should be able to clearly see these meters now. I'm going to then power up. And they ask us to take it to, what voltage are we going up to? Until the voltmeter indicates 50 volts, okay, and then record the ammeter reading in table 1. So we're going to go up to 50 volts here on this voltmeter. Just wait until we get up there. Touchy. Of course, they chose a voltage here that becomes a bit touchy. Jumping all over 42 there. Sorry. I'll get it as precise as we can. We're now at back down to 45, 55, jumping all over the place here. Bear with me. 46, 47, 48, 49.5, almost there, 50, 50.2. Okay, and our current in this is 0.263. So we can record that, 0.263 for our ammeter reading, 0.263 amps from O to D. All right, next the steps that they're going to ask us to do is going to be, I'm going to leave that set at 50 volts so I don't have to play with it again. I'm going to power down. I'm then going to move it to my next position from tap D to the tap C position. So here to here, and then I'm going to power up again. We still have our 50 volts, and if we've got the same voltage supply, but we've reduced the resistance, we should see an increase in current, which we have. That's 0.339. Okay, and then we're going to power down again. We're going to go O to B. Okay, still at 50 volts, or a little shy of 50 volts. Whoops, I just lost my my ammeter. 1 second. It went an auto off there for a moment. So we're at 0.48 or 0.489 or 490. Okay, power down. We're going to go O to A. Power back up again. And we're at 0.9. 0.915 is what I've recorded. We're going to power that down again. Okay, so that moved through all of those steps. Moving those taps, and then using your ammeter readings for each of the resistance taps, plot a current and resistance line on your attached graph sheet, clean up your work area, and away we go. So that was lab 1-5, Ohm's law versus Watt's law. Let me just zoom back out a bit here so I'm on camera. Yeah. Lab 1-5, Ohm's law, I versus R, or current versus resistance. And what we were intended to prove there was if we change the resistance but have the same fixed voltage, then we should get current increase or decrease in the same proportion. Okay? And there we go. That's it. So we'll see you in the Learning Hub.